Welcome to Phenom AI. For years, the whole story around AI has been really, really simple. Bigger is always better. Get more data, throw more power at it, build a bigger model. And honestly, it worked. It felt like this unstoppable force. But that's changing. That whole era of just explosive, endless growth, it's starting to hit a wall. Actually, it's hitting a few of them. And the scaling party might just be coming to an end.
So what are these walls? Well, today we're going to break down the 4 fundamental limits that are really starting to threaten AI's progress. We'll look at everything from real-world resistance to a looming data famine and even the architectural cracks forming in AI itself. But to really get why these walls matter so much, we have to start by looking at the engine that got us here in the first place.
All right, so what's been driving this incredible progress for the last decade? It's really all come down to one single core principle.
They're called the scaling laws, and for the longest time, they felt like actual magic. The formula was just so simple. You add more data, you add more computing power, and bam, you get a smarter AI. Every single time. It was so reliable, it almost felt like a law of physics. But that law is now being seriously tested by our very first and probably most tangible wall.
And that brings us to the physical wall. Because you see, AI doesn't just live up in the cloud. That's a metaphor. It lives in massive, hungry, power-guzzling buildings. And the real world is finally starting to push back hard.
$64 billion. Now, that's not the value of some new AI company. Nope. That's the estimated value of data center projects right here in the US that have been either blocked or seriously delayed. And why? Because of fierce opposition from local communities.
And what's really fascinating here is that this isn't your typical partisan fight. Not at all. The opposition is split almost right down the middle between Republicans and Democrats. I mean, they might disagree on why they're against it, but they all end up at the exact same conclusion. Not in our backyard.
And you can see why. People are pushing back for very real, very concrete reasons. A single data center can guzzle as much water as a small city. We're talking about constant humming noise from cooling systems, a huge strain on local power grids, and just the fear of skyrocketing utility bills. These are things that affect people's everyday lives.
Bryce Gustafson from the Citizens Action Coalition puts it perfectly. He says, it's like a revolt in the heartland. Suddenly, data centers have become the new front line for not-in-my-backyard activism. The physical infrastructure of AI is hitting a very real wall of public resistance.
Okay, so from the physical world, we now have to turn to the digital one. This second wall, it isn't made of brick and mortar. It's made of bits and bytes. You see, AI models are these voracious eaters of data, and we are, quite simply, running out of food to feed them.
This timeline is, well, it's genuinely staggering. Researchers are projecting that we could run out of our supply of high-quality public text. We're talking books, articles, journals, as early as 2026, just a couple of years from now. And by 2032, the entire stock of all public text on the internet could be gone. Just think about that for a second. AI is consuming information faster than our entire civilization can produce it.
So, what's the solution everyone is talking about? Well, just get AI to create its own training data. Sounds smart, right? But the big problem with this synthetic data is that an AI doesn't create like a human. It simplifies everything. It condenses, it remixes, it just lacks that messy, nuanced, real-world texture that makes human writing, well, human.
And when these models are trained on their own simplified, sterile outputs, they enter this degenerative cycle that researchers call model collapse. The best analogy really is making a photocopy of a photocopy. You know how it works. Each new copy loses a little bit of detail, a little bit of quality, until you're just left with a blurry, distorted mess. The model literally forgets the richness of the real world and gets trapped in an echo chamber of its own making. So we've got a physical wall and a data wall. This third wall is an internal one, the architectural wall. The very foundation of modern AI, that transformer architecture that lets models understand context, it's starting to show its age. We're hitting a point of seriously diminishing returns.
This brings us to a really strange kind of speed limit. If you look at this chart, you can see that algorithmic progress, the software, is getting better way faster than the hardware is. And this creates a bizarre bottleneck. It means that if you spend too long training a new model, say more than 9 months,
The underlying technology will have already improved so much that your brand new model is basically obsolete by the time it's even finished. It's a race you literally cannot win, and projections say we're going to hit this hard limit by 2027. And all this reveals what researchers are calling the jagged frontier of AI reasoning. It's kind of like a genius who can solve quantum physics but has no idea how to tie their own shoes. These models can pass the bar exam, but then they completely fail a simple logic puzzle. They lack basic common sense, they get stuck on early mistakes, and just throwing more and more data at them isn't fixing these deep, fundamental flaws. And what does that all add up to? A classic case of diminishing returns. To get the next, just slightly better model, companies are spending exponentially more money. I mean, look at this. The cost can jump by 30 times, while the actual performance gain you get is tiny, incremental. We're spending absolute fortunes for inches of progress.
So, with all these walls closing in, what comes next? Is this it? Is AI over? Not necessarily. This probably isn't an AI winter, but it is a forced evolution. It's a pivot away from just brute force and towards something that looks a lot more like efficiency and ingenuity.
Yeah, the future of AI is likely going to shift and shift dramatically. Instead of just scraping the entire internet for data, the focus is going to be on small, super high quality, expert curated data sets. Instead of one giant transformer model to do everything, we're probably going to see hybrid architectures that mix and match different systems for different tasks. And rather than centralizing all that power, we might see a move toward distributed computing. The mantra is truly changing from bigger is better to smarter is better. So really, the fundamental race in AI has completely changed. For a decade, the goal was simple: build the biggest thing you possibly can. Now, that finish line has just vanished. The new race is all about building the smartest, most efficient, most purposeful model. The brute force era is over. The age of intelligence? Well, that might be just beginning.